Hey everybody, it's Mr. Carr again. Today we're going to be looking at 6.2 day two. The goal today was talking about what's called special right triangles. There's two of them. There's 45, 45, 90, 30, 60, 90. So 45, 45, 90, which is also called an isosceles right triangle because two sides match up here. So this is my 45, 45, and 90 degrees like that. So one way of looking at that is that the side lengths are always in the pattern of x, x, and then x root 2. Okay, x root 2. So in a way, you know that these two have to match up. And one thing you can always do is you can take this to this, you're going to multiply it by root 2. That's a shortcut version. But I like to do these a little bit differently. Because we're dealing with a lot of similar right triangles, every 45, 45, 90 triangle is going to be similar to this version right here. It's 1, 1, and the square root of 2. Okay. And so I'm going to use that with like a little chart. The chart is going to look like this. If I do 45, 45, 90, I'm going to go 1, 1, and root 2. I'm putting the side lengths that are across from their angles. Okay. So again, that's 45 here and here. So across those are the ones, and it's going to look like this. Okay. 30, 60, 90. So this is 30 degrees. This is 60 degrees. Across the 30 degrees is just going to be an x length there. The hypotenuse, which remember is across the 90 degrees, is 2x. And then this one is x root 3. But very similarly, every 30, 60, 90 triangle is going to be similar to this one. Okay, so if it's 30 and then 60, it's 1, 2, and root 3. Here's how my little chart that I'm going to use today to solve these is going to look then. Across the 30 is 1, across the 90 is 2, the square root of 3 is across the 60. Okay, so I'm going to use those two charts for all four of these problems. So A and C here are both 45, 45, 90s. You can tell because we have a right angle and we have two sides that are congruent. Here we have a right angle and then X and X are congruent as well. For the other ones, we just know if it gives you 60 and that's 90, then the other two angles have to be 30 and 30 there. Okay, so like I said, I'm going to do this. I'm going to cheat a little bit. Sorry, I'm going to use this one. I'm going to use this chart here. And I'm going to use it again for part C here. Okay. For this one, this 30, 60, 90 chart, I'm going to use it for this problem as well as this problem. So this is how I'm going to use them. Because I've been saying how they are similar to each other, I'm going to take the given information here. So if this is 45 and 45, cross this is 6. So I'll put that there. The other unknown sides, if I call it X and Y like that, sorry about that. Okay. So 6 is across the 45. The way I drew that on the triangle, X is also across the other 45, and then Y is going to be across the 90. Okay. So now when I set up the charts just like this, I can set up my cross multiplications very easily. For example, I have 1 over 6 equals 1 over X. This one's really straightforward. The two sides have to match up in an isosceles right, so X is just going to equal to 6. But when I do the other one, I'm going to do 1 over 6 is equal to the square root of 2 over y. So now when I cross multiply, I get y is equal to 6 root 2. Okay, and that's it for that one. We found our other two sides here. Yeah, let's do 30, 60, 90 in this case. So across the 30 is 4, so I'm going to put 4 right here. I don't know this side or this side, so I'll call those x and y. So x is across the 60, and y is my hypotenuse. So I'm going to do 1 over 4 is equal to the square root of 3 over x. And then 1 over 4 is equal to 2 over y. So I can cross multiply these, and I get x is equal to 4 radical 3. And I cross multiply these, and I get y is equal to 4 times 2 is 8. Those are really straightforward ones. These next two have a little bit extra to them, but it's still the same idea. If I set up my charts the same way, so x is going to go here, here, and 9 root 6 goes here. I'm just going to solve it one time, but I'm going to do 1 over x is equal to the square root of 2 over 9 root 6. Now we can cross multiply, so I have x root 2 equals 9 root 6, and then I divide both sides by root 2. So if you remember, our radical properties, I can take the square root of 6 over the square root of 2 and make it into the square root of 6 over 2. So I can put them together into one square root. So 6 divided by 2 is going to give me 3. So my final answer here for this, the length of x is 9 radical 3. Over here, across the 30 is 5 root 3. So I'm going to put that here. And then we have v across the 60 and then w across the 90. So my two proportions I can set up, 1 over 5 root 3 equals root 3 over v. 1 over 5 root 3 is equal to 2 over w. From there, I'm just going to cross multiply that. So we have v, and then this, where we have v is equal to 5 root 3 multiplied by root 3. Once again, think about our radical properties. The square root of 3 times the square root of 3 is going to turn into just 3. So I multiply those together, turn into 3. 5 times 3 gives me 15. And that's it for v. Over here, we'll do the same thing. We cross multiply. So w is equal to 2 times 5 root 3. Here, I'm going to multiply just the 2 and the 5 together because those are both outside the radical. So w equals 10 radical 3. We're going to have a lot of exact answers, and we're going to leave a lot of these answers with our radical symbols in them. And that's actually it for today. Our special right triangles are two of them. It's 30, 60, 90, and the 45, 45, 90. I really like these charts. I think they're very handy. So you're just going to set up this chart. As soon as you see enough information to say it's a 45, 45, 90, you're going to set up this chart. And these are just the sides that are across their given angles. If you see a 30, 60, 90, you set up this chart. And then after that, it's all cross multiplication. You just have to make sure you remember how to do certain operations with our radicals then. All right. And that is it for today. So 30, 60, 90s, 45, 45, 90s, that's a main idea. So that's it. Take care, everybody.